Cool. All right, let's go ahead and actually try to design this Turing machine to work with this language of equal number of zeros to equal number of ones. The way that I'm going to run this first example is that aspect of read from left to right and find the first digit you can. So if I find that 0, my second quest is then going to be to find its match, which would then be to find this 1. What's then going to happen is that it's going to basically be viewed as old school typewriter, is that the little pointer is going to go all the way back to the left and we're going to start over again. So you would then find the 0 and the 1 and then back to the beginning again. And then you'd find the 0 and the 1 back to the beginning again. And then on our last pass, we're going to see that everything has been accounted for. So we're going to then move into a state of acceptance. So a little bit more formally, I'm going to kind of show exactly how the pointer is going to read and write and move left and right. So if you go back to the schematics of the Turing machine, that's all I can do is I have my little pointer, which is, let's say, going to be pointing at the very first character here. That thing has the ability to read and write, and then it can move left and right if it wants to. So initially it's staring at that 0 and it's like, sweet, I found a digit. Great. Now I'm going to move into a new quest. So my first quest is then going to be something that I like to call seek digit. And that's going to actually be a state in our diagram. My current mission is to find a digit. I don't care what digit I find, 0, 1, I don't care. Once I find it, I'm then going to change missions. So that's what's happening here, is that I've found that 0, so I'm going to cross it out. Like I'm accounting for it. It effectively is going to be like in your back pocket because you know that you found a 0. So I'm going to take that 0 and I'm going to swap it out to be an X. And then my new mission is to actually find its match, which is going to be a 1. So because I found a 0, I'm now seeking a 1, and my pointer is going to click 1 over. At that point in time, I'm going to be able to read that 0, but I'm still seeking a 1. So my mission is still seek 1. So I'm not going to do anything to that 0. I'm just going to jump over it. You could think about it as reading a 0 and writing a 0 if you really wanted to kind of be neurotic with that, of like, I had to read a 0 and I had to paste something. Here, I'm just going to let me pass on over it. You could technically swap them out, but that is what it is. So we seek that. So we're still kind of moving towards that 1. Now you can see that we're actually going to find this nice little 1. So upon still seeking 1, what's going to emerge is that I'm going to cross that 1 out. Great, awesome, I found a 1. So I'm going to change the 1 into an X. And now my new goal is going to change. So I went from seeking a digit to when I found the 0, my new goal then became to find a 1. Once I find the 1, I'm going to move my way back. So I'm going to start over. So my new quest is then going to be to seek the start. And this is where that typewriter aspect is going to come into play. So it's go across, come back, go across, come back, go across, come back. So when I go back, my pointer is now going to be marching the other way. The 0 is not the start, so I'm going to seek start some more, which is going to tell me that that little pointer has to move 1 more. Still not the start. So I'm going to click 1 more over. And then you're going to see that I'm going to be staring at a blank. So that little blank, that very first blank, is then going to denote that, hey, I've actually made it to the start of the string, which is actually why when I erased things, I did not actually erase them. I changed them into an X because I want to identify where the string starts, and I want to be able to compare that to what's something that's actually been dealt with. So the X is going to be something that has been dealt with. The blanks then are going to essentially become bookends for my string. So it's going to have the starting, and you can also see that it'll be the end as well. So that's basically what my machine is going to do over and over and over and over and over again. So I'm going to swap into an implementation of the state diagram to kind of show how that looks. And then we're actually going to come back and chat about how to build that state diagram. And then we're going to rinse and repeat that a little bit. So I'm going to swap this into Safari Land and share that. So there's going to be a state diagram. So it's a little bit of spoiler alert, so don't look at it too closely, or you can look at it and try to make some generalizations out of it. But you're going to see the goals that we've kind of briefly outlined, is that my initial mission is going to be to seek a digit. Once I have the digit, I'm going to go seeking its friend. Once I find its friend, I'm going to try to march on backwards. So when I look at my string of 001101, if I load this up and make sure everything is great, you can see that process unfold. So that was exactly the steps that I just hand sketched out. Now my mission starts over again. So I'm going to seek a digit, which I find, and I'm going to find its friend, which I find, and then I'm going to march on back again. And then I'm going to start all over again. So I'm going to seek a digit, find its friend, march on back. And then we move into a final accepted level once we have everything X'd out. So if you're in this mission of trying to find a digit, what's going to happen is that you're going to go across the entire string and you're going to end up at that final blank. And if that happens, you're accepted and everything is great. So that's kind of this cute way that we can kind of showcase how this machine is going to parse through this particular input and actually validate it as being operational. What you can see up on top is going to be this nice little state diagram. And that's what we want to work towards building next. So we can have this convenient, tidy way to actually talk about how this Turing machine is working. And then we can actually go through and actually implement it and play around with various inputs, then chat about all of these questions of efficiencies and all of the goodies that are then going to come with that. So right now we're just going to have this as a site that we can play around with. So we'll come back to this in a little bit, but the site is called turingmachine.io, and it's great for playing around with some of these things. So this is one that we built up. It has some pretty tidy syntax that'll make more sense here in a second. And it gives us this chance to play through things that we know should work, but it also gives us a chance to play through things that don't work as well. So I think I'm going to pause this video and then jump back to the notes to then build up this machine and then chat about the notational aspects of it. And then we're going to rinse and repeat and try to look through this in another example.